Assalamualaikum and good day everyone. In this video, I will explain to you what is phasor representation for your chapter 2 AC analysis. So before we actually can solve this equation, these problems, I need to explain to you what is sinusoidal signal, how to represent sinusoidal signal in phasor representation. So let's go directly to the problem. So for example, you have one signal and that signal is given by, okay, let's say we take this equation lah, V1, sorry. So V1 is negative 10 cosine omega t plus 50. So if you want to do this representation, you need to know in your hand, or you need to know two things. Okay, first is what is the amplitude. This is the amplitude of that phasor, and also this is the angle of that phasor lah. Okay, this is the angle. So if you have V1 and you want to represent it in a phasor representation, what you do is you draw these four quadrants first and then determine what is the signal or what is the type of sinusoidal waveform. In this problem here, it is a cosine, and when you have cosine, this axis here is gonna be your reference, your starting point. Okay, the next thing is, let's see what is the amplitude. Amplitude is negative 10. So how do you represent negative 10? If it is a positive 10, you will draw it like this. This is positive 10. However, this is a negative 10, meaning that amplitude or that vector will start at this direction here. So this is negative 10. This is positive 10. Okay. So next thing is, from this negative 10 here, you have to move positive 50. So where to move this vector? Is it you want to move upward or downward? So in this phasor representation, you have to know this, how to say, these are the rules lah. If you move this way or the counterclockwise, this means the angles are positive, and when you move this clockwise direction, this means the angle is moving in the negative direction. So when you have the initial point here, this negative 10, isn't it? This is the negative 10, and then you want to move positive 50. Positive 50. Positive 50 meaning in this direction. So when you try to like continue this direction, meaning from here you need to move downward, positive. So positive 50, you have to move it downward, and this vector, the final vector, would be somewhere here. This is your V1. Oh, sorry. This is your V1. V1 phasor representation. How about the second one? The second one is V2 equals to 12 sine omega t minus 10. What is the amplitude? Amplitude is plus 12, and the angle is negative 10. This is the angle. This is the amplitude of the vector, of the phasor. So since this is a sine, so your reference would be somewhere from here, this axis. Okay, so starting from this axis, you're going to draw this phasor V2. The amplitude is positive 12, meaning the direction is this way, positive. This is positive 12. And you can anticipate that if it is a negative 12, then it will be pointed upward. Okay, so in this case, this is positive 12, and then the angle is negative. So looking at this apa ni reference, negative meaning you have to move this way, isn't it? So this 12 amplitude of 12 phasor, you will move it this way with an angle of negative 10. So the final phasor will be somewhere here. And that is your V2. Oh, oh, no. Okay, let's redraw. Okay, this is your V2. And the angle here is 10, kan? 10. From here to here, it is 10. This way, it is 50. So here, the question asks you which sinusoid is leading, either V2 or V1. So if you say it this way and you try to like move in the clockwise direction like this, okay, you can see that which one is leading. Obviously, it is V2. V2 is leading, isn't it? Is ahead of V1. So you can say V2 leads V1 with how many degrees? You have to calculate this difference here. How to calculate it? You know, one quadrant gives you a 90 degree. And if you have here as 50 and here side, and at this side is 10, meaning you are left with this theta here is equals to 30, isn't it? Theta is 90. The whole thing here is 90 degree, minus with 50 degree here, and another 10, and your theta would be 30. So V2 leads V1 by 30 degree. So that is your answer. You can also say V1 lags V2, meaning V1 is lagging, is falling behind, is following behind V2. Okay, by how many degrees? Also by 30 degree. Okay, so you can change them, but you need to also be careful about where to place this the phases. Okay, so let's try another one. Okay, this one, it gives you I1 equals to negative 4 sine 377t plus 25. And also the second signal, cosine signal, 5 cosine 377t minus 40. Let's draw this. So you need to draw the 4 quadrant. 4 quadrant. And then for the first signal, I1, it is a sine signal, so meaning this is your reference. Sine negative. Negative meaning you have to put it that way, isn't it? This way, negative 4. And then the angle is positive 25. You can just redraw this angle representation first in case you like forgotten. Okay, this may guide you lah to do the to draw the phases that they are given to you. So if the signal is positive 25, meaning from this phasor negative 4, it will move that way, this way. How many? 25 degree. So meaning the final one would be somewhere here. Okay, this is your I1. Okay, let's move to the other one, I2. Take another color here. I'll take green, and then this is a cosine signal. So cosine means this is your reference. Positive 5, meaning this way, positive 5. Lepas tu, the angle is negative 40. So kalau negative, dia kena turun ke bawah lah. So negative 40. Okay, negative 40. Meaning the phasor, the vector will be here. Okay. Sorry lah, it should be apa ni, proportional lah kan. Ni patutnya sama but I extend pula, terextend. Should be something like this. Oh, I cannot move it. Oh, cannot. Tak apalah. Okay, so this is your I2. So now, which one leads? Take one, like for example, take one as your reference. Let's say I want to refer to I1. Okay, so I1 here, if we refer it like this, you can either see it as leading or lagging. So let's say if you move it this way, I can see that I2 is leading. I can say that lah. I can say I2 is leading, isn't it? Let's say I say I2 is leading. I2 leads I1 by I2 leads by this angle here. So we have 90 degree here, and then from here to here we're gonna have 50 degree, and also here it's 65, 65 degree, isn't it? So the total angle from here to here is the summation of these angles. So 65 plus 90 plus 50. How much? Calculator. 65 tambah 90 tambah 50. 205 degrees. Okay. What is the answer? I1 leads I2 155. Is this wrong? Okay, like I said before, it depends on which signal are you referring to. Like for example here, let's say we take I1. Okay, I1, if I see I1, I can say how to make I1 leads I2, meaning the angle is counted from here to here. Okay, so if I1 leads, the angle is a bit different. The angle starts from here, I2, and you have to add all the way until I1 here. So you have how many? 40 plus 90, and also another 25. How much is that? 9, 10, 15. Okay, so I1 leads I2. I1 is ahead of I2 by 155 degrees. So this is the same as the given answer here. I1 leads I2 by 155 degree. And the first statement here is also correct. So both are correct. This is acceptable. Both of them are acceptable. Okay. So thank you.